Hello, in this video we're going to be talking about what are Python sets. So we're going to be going through just a quick guide to Python sets. So what are sets? It's a Python data type that holds an unordered collection of unique objects, very similar to a list. The one big difference is that every member of that collection is unique, and the membership requirements are the objects have to be hashable. That's why they're going to be unique. So dictionaries, lists, and other sets are not hashable, so they can't be members of a set. They can be members of a list, but they can't be members of a set. Numbers, strings, and tuples, those guys can be hashed, and they can be included into a set. Creating an empty set's pretty easy. You just have just call set and then give it a name. It's built in. So we've created an empty set here. There are no members here. And then if you wanted to create one with members already, you could do this and then print it out, and then I'll show you that it has it. So pretty much like some collections you've probably seen in the past. Now let's try to see if we try to make one with duplicate members. This is the big important part of probably one of the most important parts of sets is that they are unique. So here we go. We've got shapes, just like we had before. So we had shapes. It was circle, triangle, and square, and that worked. Made a little set there. Now we make another one here, but we do circle, circle, triangle, square. So you have here a duplicate. Now it'll happily accept it, but it actually won't make a duplicate of circle. We'll still end up with just one circle. Sets are iterables, just like lists. So here we've got our our circle, circle, triangle, square here. And if you remember from previously, it's not actually going to make two circles, it's only going to be one circle. So if we do a for loop through here, it's going to print out square, circle, triangle. To add an item to the set, you call the add function on the set itself. So we had an empty set here called shapes, and we want to add circle to it. We could just call the add function and add the string circle. And then we can print it out and see now we do have a single member to this set. If you add duplicate items to the set, pretty much nothing happens. So here we go. We've got an empty set. We add circle. Then we print. There's still only one circle, keeping in that idea that a set is unique. Well, the members of the set are unique. You can also add multiple items to a set. So we can see here. We can update and add this list here, and that will be turned in or added to or updated rather to the set. All right. You can also count, just like you would with a list. You can get the length. So here we go. We've got our empty set, and then we're going to add 3 items to it, and we ask for the length of shapes by saying len. All right, and we'll say we've got 3. So pretty straightforward. If you've handled lists, you'll see they're very, very similar with some more unique things. Let's see. Oh, and we can check for membership too. So we've got a list here that is shapes, and we want to see if circle is in that set. And yes, it is. Unfortunately, my indentation, I'm using Reveal.js, and every now and then it drops my my indentations. But this should be indented, as you probably look at this code. This is pretty simple, so you probably saw that error before I did. Okay. We can also well, actually no, we can't. I got ahead of myself there. Accessing a member of a set. Okay, so we're gonna make an empty set, just like we did before. It's the same kind of empty set we've been making over and over again with the circle, triangle, and square strings. And if we try to say, I want to print out the index 1, like you would in a list, it's going to say it can't do that. So there's one more little difference between sets and lists there. So be aware of that. Remove a member from a set. Discard removes a member if it's present. So here we've got our same set we've been dealing with, and we're going to say we want to discard the circle, and we're going to print that set again, and you can see it just says square, triangle, it's thrown away the circle. Remove a member for the set. It'll do it even if it doesn't exist. So here we go, we've got our same thing of circle, triangle, square, and we're going to say we want to discard doggy. Well, it doesn't do anything. It also doesn't complain. It just happily discards it. Says, you wanted me to throw away doggy? There was no doggy, so my job was pretty easy. Remove removes a member, but throws an error if it doesn't exist. All right, so this is the exact same code we had before. The only difference is instead of discard, we are using remove. All right, so you have that same set we've been playing with this whole time, and now we're going to remove doggy and then print shapes. It won't do it. It's going to throw a key error. So if for whatever reason you wanted some kind of almost confirmation that you had removed an item from a set, this could be useful for you, but most commonly you'll be using discard. You can also remove an arbitrary member of the set. So if you call, so we have our shapes here, and we're going to call pop and give it to shape, and then we're going to print shape, and it's going to give you square. Your mileage may vary because sometimes it, like I said, it's going to be an arbitrary member. It's not necessarily going to be the first or last one. Remove all members from a set. So if we've got our same set here of shapes. If we decide we want to clear it and start over again, we can just call the clear function, and it'll wipe them all out. So when we call print on shapes, it just says it's just an empty set. Set equality. This is where we start getting into some interesting things. So we have our same shape set that we've been dealing with, but now we have more shapes. This is a whole nother set. This also has the string circle, triangle, and square, and we can see if these are equal to each other. So if shapes equals more shapes, we can actually test to see if sets are equal to each other. So in this example, of course, the sets are equal. We'll do one more example where we know that they're not going to be equal. So in this one, we have added a pentagon to more shapes. So more shapes has one more member than shapes does. And we're going to do that same thing. Oh, see, it did it again. It got that in there, but this should be still readable for you, hopefully. So we're just going to check to see, if shapes equals more shapes, and test that and see if it's true. Of course, you can see from here that more shapes is not the same thing as shapes because we have a pentagon in there, so it is going to fail. Let's see. Sets are only equal if each and every member of that set is contained, and the other subsets and supersets are not equal. You may have noticed supersets and subsets. We're kind of hinting at some things that are going to be coming up. But wait, we have still more. Copying a set. This is a bit of a warning. So here we go. We've got our trusty set of shapes, or yes, we'll call that. And sometimes you can just do this kind of thing. So we've got shapes here, and we are just going to assign shapes to more shapes. And then we're going to have in more shapes, we're going to discard that circle and then print out the original variable. And you'll see it actually, you might not expect this behavior, that sometimes in Python, you think you'll be doing a full copy by just doing an assignment like this, and sometimes you won't. You have to be aware of when it happens and when it does, and the reasons behind it are a little more kind of out of scope for this video, but it's something to be aware of, and sets are like that. If you want to copy a set, you need to actually call the copy function. So here we go, we're doing the same exact thing. We're going to actually make a copy of shapes and put it inside of more shapes, and then discard the circle, and now we can print out shapes, and we see it has not been affected. Only more shapes has been affected. I only really include this because this is a common gotcha that some people complain about. Frozen sets, immutable sets, they can't be changed. Frozen sets are hashable. Remember when earlier we were saying about how normally a set can't be a member of another set? A frozen set can, because they are hashable, and that's because they're immutable. So here we go. We specifically can call frozen set, and we treat it basically just like a normal set, except instead of just calling set, we call frozen set. And now, just to test things out, we're going to try to add pentagon. Well, it's not going to let you do that. Nope, not going to let you do that because it's a frozen, immutable set. It's frozen. It can't be changed. Okay, let's take it to the next level. You may have wondered if there's any kind of relationship with Python sets and mathematical sets, and you would be on the right track here. Here's a quick little example. Here's a difference. So we have two sets, doctor and parents. In doctors, we have Bob, Dave, and Mary, and in parents, we have Bob, Katie, and Susie. Now we call the function difference on the set doctors. We're going to pass the argument of parents, so we're going to see what that difference is, and give it this variable. And we're going to get Mary and Dave. And that's because Mary and Dave are in doctors, but they are not parents. Bob is in both. As you can see, we can reverse this and say what the difference is with parents. So we are calling difference on parents with doctors, and that is going to give us Susie and Kate. Susie and Kate are doctors, but not parents. Bob is in both. Now, we have intersection. We have our same list of doctors and parents. We want to find what is the intersection. All right. We could probably do this either way and still get the same answer, unlike the previous one. So we've got doctors. We're going to call it intersection and give it parents. So we want to find out where do these two sets intersect. And the answer is Bob. Bob is the only one in both sets. Is subset is another one we've got. So this one's going to be a little bit different. So this is of data, and it is a set of integers. So 1, 2, 3, 4, 5, 6. And we have subdata, which is 4, 5, 6. We want to know if subdata is a subset of data. And, well, that is true because 4, 5, 6. So yes, it is a subset. So you can test to see if things are subsets, and you can also see if things are supersets. So we have the same data things here. So we got data, then subdata, and then we want to know if data is a superset of subdata, and that is also true. And I think that's it. So I hope you've enjoyed learning about sets, and thank you for watching. If you like this video, please like and subscribe, and if you have any questions, please leave them in the comments below. And if you have any topics you'd like me to cover in the future, please leave those in the comments below too. Thank you.